students. In today's discussion, I'll be teaching you chapter 1 of class 9, Science, Matter in Our Surrounding. So, what is matter? Matter is anything that have volume, mass and occupies space. Matter is made up of particles. So, here in the diagram, we can clearly see these are salt particles, these are water particles. So, when we mix both of them, a salt water is formed in which the salt particles exist between the spaces of the water particles. So when we dissolve salt in water, the particles of salt get into the spaces between the particles of water. So as matter is made up of small particles, now we'll discuss how small are these particles of matter. The particles of matter are very small. So we'll understand with the help of an experiment. A crystal of potassium permanganate can color a large volume of water, which keep on dividing themselves into smaller and smaller particles. The smell can be detected even after repeated dilution. So in this experiment, 100 milliliter of water has been taken, clean water. In it, a spoon of potassium permanganate is put. So there are 1, 2, 3, 4 jars of water, each having same 100 ml of water. And see the color, same potassium permanganate, 10 gram, 10 ml is put from this jar to this jar, and from this jar to this jar, and from this jar to this jar. So even after the color becomes faded, but still it is visible. So this shows that how potassium permanganate particles mingle with the water particles after repeated dilution. So till the time we have discussed, the particles of matter have space between them. This have been already been proved that sugar particles, which is smaller than water particles, fit in the space between the water molecules or water particles. The sugar particles fit in the space of between water particles. Potassium permanganate also fits in the space between the water particles. So this proves that the particles of matter have space between them. So another characteristics or feature of the particles of matter is that the particles of matter are continuously moving. So there are two experiments. One is in a room. If we light up an incense stick, the aroma will spread to the entire room. In this experiment, if in a glass tumbler filled with water, at one side I put red ink and on the other a drop of honey has been put, and the water is kept undisturbed. So after a while, we see that the entire water is filled with honey particles and red ink particles. This shows that the particles of matter are continuously moving. So temperature, movement of particles and Ke. What is Ke? Kinetic energy. There's energy which is produced by the virtue of motion. All these are directly in proportion. Means that if temperature increases, the movement of particle also increase, and this will also increase the kinetic energy. So in our discussion, the experiment showed that the particles can intermix on their own. So we have seen that how the incense stick aroma mixed with the air particles in their own. We have seen that how the red ink and the honey and the water intermix on their own. So this intermix of two different types of matter is called diffusion. Important. What is diffusion? Diffusion is intermixing of two different types of matter. On heating, diffusion rate accelerates. Accelerates means increased. As we have seen above that, all are directly proportional. Temperature increase, movement of particle increase, and kinetic energy also increase. So the diffusion rate increase with the increase in temperature. So let us discuss on the other characteristics of matter. The particles of matter have force of attraction acting between them. So each particle of matter have force of attraction, some kind of attraction force, and this force of attraction keeps the particles together. Otherwise, particles move. The strength of the force of attraction is highest in solid and weakest in gas. So solid, the particles' force of attraction is highest, and in gas, the particle force of attraction is the weakest or lowest. So these are the particles in solid. These are closely packed and the force of attraction is very high. That's the reason solid have definite shape and volume. Liquid, on the other hand, the particles are spaced and hence the force of attraction is weaker than solid. On the other hand, gas have particles force of attraction very low. That is the reason gas have no definite shape and volume. So states of matter, different types of matter is around us and it's of different state. So we can see that matter exists in the form of solid, liquid and gas. These states of matter to the variation of characteristics of the particles of matter. So how the particles are placed, the state of matter is given a name. So in this picture we can see that in the solid state the particles are very closely packed. In the liquid state, particles are less closely packed in comparison to solid. The gaseous state, the particles are far away, it is very loosely packed. So I have jotted down the characteristics of the three states of matter: solid, liquid and gas. In solid, the definite of shape, solid have definite shape, size and volume. Liquid, they have definite volume but no definite shape. And gas, there is no definite shape and volume. It takes up the shape of container. Particles of solid are very closely packed. Liquid, they are less closely packed, and in gas, they are very less closely packed or sparsely packed. Next is K. Kinetic energy is lowest. The movement of particle is lowest. The particles in solid vibrate. It cannot move. In liquid, the particles do move and it's more than solid. But in gas, the K is the highest. The particles move very frequently, at a very high rate. Next, force of attraction among particles is the highest. As the force of attraction is highest, the K is lowest. It doesn't allow the particles to move. Lower than solid, force of attraction. In gas, the force of attraction is lowest and hence the K is highest. Why? It allows the particles to move. Next, diffusion rate is lowest. We have already learned about diffusion. This is rate of mixing of two different matters. So diffusion rate is lowest as the particles cannot move. It is higher than solid and diffusion is highest in gas. So in solid things cannot be compressed. It cannot be put, the pressure cannot be put to change its size or shape, as there is very less space between them. So particles have very less space between them, so the solid particles cannot be compressed. But there are certain particles, certain materials of solid like sponge which can be compressed because there are air pockets. Liquid, on the other hand, the compression is more than solid. Gas, the compression is highest. There's a reason in our kitchen we have LPG, liquid petroleum gas, in cylinder. So 10 kilogram of gas is compressed and put in a cylinder. So that can be only possible in the case of gas because the particles have space between them that can be compressed in a small container. So how do aquatic animals like fish breathe inside the water? So oxygen gas is diffused in water. Diffused means mixed in water. And this helps the aquatic animal to breathe. Fish have gills which separate dissolved oxygen from water. So let us discuss more about the gaseous state of matter. So we have observed that gases are highly compressible as compared to solid and liquids. The liquefied petroleum gas or LPG cylinder that we use in our home for cooking, or the oxygen cylinder supplied in hospital, are compressed gas. So these gases are compressed. Compressed natural gas or CNG is used as fuel these days in vehicles. Due to the high compressibility into small cylinders, it can be transported easily. So as gas is highly compressible, it can be transported. It can be compressed in small cylinders and be transported very easily. So change of the state of matter. We have already discussed about the three states of matter as solid, liquid, gas. Now we'll discuss how the states of matters are changed. So when solid is heated, the K, the kinetic energy of particles increase. The particle starts to vibrate. When the heat overcomes the force of attraction in the particles. So this means that when the heat increases and it overcomes the force of attraction of the particles. Now the particles are vibrating vigorously and it no longer can stick to its position. Liquid state occurs. So the point at which the strength of force of attraction between the particles change from solid to liquid, that point is known as the melting point. So the melting point of a solid is an indication of the strength of the force of attraction between its particles. Melting point of ice is 273.15 degree Kelvin. The process in which the solid change to liquid is known as melting or fusion. So we'll discuss on the latent heat of fusion. What is the meaning of latent? Latent means hidden. The heat energy which is hidden, it is not measured. So latent heat of fusion is the constant heat or constant temperature which remains while the solid is converted to liquid state. So when the solid is converted into liquid state, the temperature remains constant. So that constant temperature is called latent heat of fusion. The heat energy is absorbed in solid, for example ice, without showing any rise in temperature. And this energy is used to convert solid ice to liquid water. Latent heat of fusion of water is 273 degree K or 0 degree C. What is C? Celsius. So at this point, that is 273 degree Kelvin or 0 degree C, water holds more energy. So next is latent heat of vaporization. Latent heat of vaporization is that constant temperature when liquid changes to gaseous state. The temperature at which liquid starts boiling at atmospheric pressure is known as boiling point. So when the liquid starts boiling at the same atmospheric pressure, it is known as boiling point. So boiling point of water is 373 degrees C, 373 K or 100 degrees C. 273 plus 100 equal to 373 degree K. Now very important. Why steam holds more energy than or steam is more harmful than boiling water? Answer: this is due to the latent heat of vaporization, where steam holds more energy than water at 100 degrees C or 273 Kelvin because of the extra energy absorbed. So this diagram states the interconversion of the three states of matter, how the matter is changed from one state to another. So when liquid is heated, it is called fusion and it becomes liquid. When liquid is cooled, it is called condensation. When liquid is heated and changed to gas, it is called evaporation. When gas is cooled, and comes to liquid, it is called condensation. I said here condensation, it is solidification. When liquid changes to solid, and when the solid directly goes to gas without becoming liquid, it is known as sublimation. When gas directly comes to liquid, when gas directly changes to solid without becoming liquid, it is known as deposition. So this chart is very important. So in this diagram, what this diagram states that by applying pressure, particles of matter are brought close together. So when we apply pressure on gas, we are applying pressure on gas, it becomes liquid. So applying pressure and reducing temperature can liquefy gas. So gas can be liquefied by applying pressure. Have you heard of solid carbon dioxide gas? It is stored under high pressure. So when carbon dioxide gas is put pressure, it becomes liquid, and when more pressure is applied, then the liquid carbon dioxide becomes solid. So solid ice or solid carbon dioxide is carbon dioxide gas stored under high pressure. Solid carbon dioxide can be converted directly to gaseous state on decrease of pressure without coming to liquid state. This is known as what? From gas to solid is known as deposition. We have just read this deposition from gas to solid. And when solid to gas, it is known as sublimation. So here in the example, dry ice converts directly to carbon dioxide gas. It is known as sublimation. So next topic of discussion is evaporation. When liquid change to gas without boiling point, it is known as evaporation. At any temperature, the particles have Ke. So at any temperature, the particles in water or in liquid have kinetic energy. What is kinetic energy? The energy which helps the particles to move. In liquid, the particles reach the surface due to Ke and is able to break away from the force of attraction and gets converted to vapor. Let's understand with the help of a diagram. Suppose this is the surface, water surface. These are water particles. At a temperature, it has acquired kinetic energy and is moving. So when this particle reaches the surface, it has acquired Ke, and with that force, it's able to break from the force of attraction of this liquid and becomes vapor. So from liquid state, it becomes vapor state without any additional heat. This is known as evaporation. So evaporation increases with an increase in surface area. We know that the evaporation is a surface phenomena. So it happens, the liquid changes to vapor at the surface. If the surface area is increased, for example, while putting the clothes for drying, we spread them, and this increases surface area. The evaporation increases. An increase in temperature. What happens with increase in temperature? The Ke also increases. The particles with the increased temperature will now speed up, will now have greater movement. With increasing temperature, more number of particles get enough kinetic energy to go into vapor state. A decrease in humidity. What is humidity? Amount of water vapor present in the air. If that is reduced, the air is dried. So the air cannot hold any more definite amount of water vapor at a given temperature. Then the evaporation will also increase. Increase in wind speed. It's common observation that clothes dry faster on a windy day. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. So automatically the wind helps the water vapor carried away from the surface, and that area becomes dry. So how evaporation causes cooling? In an open vessel which is not closed, it is not closed by lid, it is open, liquid keeps on evaporating. So if a hot cup of tea is kept open, then the tea will be cooled faster than a cup which has got a lid. The particles of liquid absorb energy from the surrounding to regain the energy lost during evaporation. This absorption of energy from the surrounding makes the surrounding cold. What does this line say? That the evaporation of the hot particle, a hot liquid evaporates, and the loss of heat is absorbed by the surrounding heat. So the surrounding area will get cooled. Now what happens when we pour some acetone or nail polish remover on your palm? The particles gain energy from the palm or surrounding and evaporates, causing the palm to feel cool. So the nail polish remover takes up heat from the surrounding, from the palm of the hand, and it changes into vapor state. That's what you have learned, latent heat of vaporization. So that causes the palm to get cool. After a hot sunny day, people sprinkle water on the roof or open ground because the large latent heat of vaporization of water begins to cool the hot surface. Next, why do we wear cotton clothes in summer? So during summer we perspire, we sweat more because of the mechanism of the body which keeps us cool. We know that during evaporation the particles of the surface liquid gains energy from the surrounding or the body surface and change into vapor state. What does this line mean? That we know that evaporation takes up body heat and converts it into vaporization state. So the body will become cool. The heat energy equals to the latent heat of vaporization is absorbed from the body, leaving the body cool. Cotton being good absorber of water helps in absorbing the sweat and exposing it to the atmosphere for easy evaporation. So why do we see water droplets on the outer surface of glass containing icy water, very cold water? So ice cold water in a tumbler, we will see water on the outer surface of the tumbler. The water vapor present in the air on coming in contact with the cold glass of water loses its energy and gets converted to liquid state. So from gas to liquid, what is the conversion known as? Condensation. And this makes the water vapor present to condense in the condense to liquid state in the surface of the tumbler body, tumbler outer. So this brings to the end of the chapter. Thank you very much. Please do subscribe and forward this video to your near and dear friends. Happy studying.